Ions. Ions are charged particles formed when atoms gain or lose electrons. Atoms consist of protons, neutrons, and electrons. If an atom gains electrons, it becomes negatively charged, an ion, and if it loses electrons, it becomes positively charged, cation. The charge of an ion is denoted by a superscript after its chemical symbol. For example, Cl- represents a chloride ion, an ion, and Na+ represents a sodium ion, cation. Isotopes are variants of a chemical element that have the same number of protons but different numbers of neutrons in their atomic nuclei. This means isotopes of a particular element have the same atomic number, which defines the element, but different atomic masses. For example, carbon has 3 isotopes, carbon-12, carbon-13, and carbon-14. All 3 isotopes have 6 protons, since they are all carbon, but they differ in the number of neutrons. Carbon-12 has 6 neutrons, carbon-13 has 7 neutrons, and carbon-14 has 8 neutrons. There are 2 types of isotopes. 1. Radioactive isotopes. Some isotopes are radioactive, meaning they undergo radioactive decay over time, emitting radiation. Carbon-14 is an example of a radioactive isotope used in carbon dating for archaeological and geological purposes. 2. Stable isotopes. Not all isotopes are radioactive. Many isotopes are stable and do not undergo radioactive decay. Isotopes play crucial roles in various scientific fields, including geology, archaeology, medicine, and nuclear physics. Scientists use isotopic analysis to study the age of rocks, date archaeological artifacts, trace chemical reactions, and diagnose medical conditions, among other applications. Bonds. Bonds are forces that hold atoms together to form molecules or compounds. There are several types of chemical bonds, and they involve the sharing or transfer of electrons between atoms. The 3 main types of chemical bonds are ionic bonds, formed between ions of opposite charges, cation and anion. Involves the transfer of electrons from one atom to another. Results in the formation of ionic compounds. Covalent bonds. Formed when atoms share electrons to achieve a stable electron configuration. Common in molecules where atoms are held together by shared electron pairs. Can be single, double, or triple bonds, depending on the number of shared electron pairs. Metallic bonds. Found in metals, where atoms share a sea of electrons. Electrons move freely between metal atoms. Gives metals their characteristic properties like conductivity and malleability. Polar and nonpolar covalent bonds. Within covalent bonds, there are polar and nonpolar bonds. In polar covalent bonds, electrons are shared unevenly, creating partial charges. In nonpolar covalent bonds, electrons are shared equally between atoms. Hydrogen bonds. A special type of bond between a hydrogen atom in a polar covalent bond and an electronegative atom, usually oxygen, nitrogen, or fluorine, in another molecule. Important in the structure of water molecules and the stability of biological molecules like DNA. Understanding these types of bonds helps explain the properties and behaviors of different substances in chemistry.